Today we will start our first lecture in this course, and this is the way that we will structure our course lectures. So I will upload videos for the lecture while I'm writing down the notes on my iPad, and I will post online a PDF for the lecture itself after I finish it. You should be watching the video or the lecture during our regular lecture time, and you can pause and start to ask me questions. I will be available during this regular lecture time to take your questions. And the first chapter is revision, so we can review what you learned in circuits, and we will review what we need for this course. We will start by doing a revision for AC circuits, then we will do a revision for single phase AC circuits. So we will do DC circuits and we will do AC circuits. In DC circuit, we will start by reviewing what are the elements we have, what are the laws we have, then we will solve two examples, and this is what I will try to do during today's lecture, lecture 1, and then we will move forward to AC circuits. So the first part is for today's lecture is DC circuits. This is what we will review. In DC circuits, we have elements in any circuits. So in DC circuits, we have elements. So what are the elements we have in circuits? So we have mainly two types of elements. These two types of elements can be sources, and the element can be a load. And a source can be a voltage source, or the source can be a current source. And for the load can be a resistance, an inductance, or a capacitance. We will learn in details about inductances when we go to magnetic circuits, and also when we go to AC circuits we will learn again about L and C, and we will know why in DC circuits just we will consider R. So let's start by the first type of elements, and this type of elements is sources. So for sources, we have general two types of sources. The first type of sources is called independent source. And this independent source can be a voltage source or a current source. Or a current source. So for the independent voltage source, this is the symbol we use in the circuit. So when you see this symbol means you have an independent source or uncontrolled source. And for voltages or for voltage source, we will have polarity or positive and negative polarity to indicate that we have a voltage source. And for current source, we will have an arrow which indicates that we have a current source. For voltage source or current source, you will be given one piece of information and there will be one unknown. For example, for the voltage source, you have two terminals for the voltage source, and it is given that this terminal here is positive based on the positive here, and this terminal here is negative, which means this terminal has a higher potential or higher voltage compared to the other terminal. So if we sketch an arrow which indicates where is the higher voltage, so here is the higher voltage, this is where the voltage is higher, and the value of this voltage will be given So this value will be given, say, X volt. So this X is given. Okay, so for example, we have a voltage source, and this voltage source is 3 volt. So based on this data given, we know that this point has a less voltage compared to this volt or this point, and the difference between them is 3 volt. So if this point voltage is 0.5, for example, this point voltage will be 3.5 volt. The difference between them is 3, and this one here has the higher potential. So when we see a voltage source in our circuit, we will be given one value for the voltage, and we will be given the polarity. So the voltage source, you have two pieces of information given: the polarity or the direction of the voltage, where is negative and where is positive, and the value of the voltage itself. But what is unknown for a voltage source? The unknown is what is the current going out of the voltage source. So the unknown, if we have a voltage source, what we need to calculate is what is the value of the current and where is the direction of the current. So we need to calculate the current as value, and we need to calculate the current as direction. So how many amperes are supplied by this source, and where is the direction for this current? We will know later on how we can deal with this. For the current source, you will be given a value for the current, say X in ampere, and X is the value of the ampere current given. And this current is flowing in this direction, so the current is flowing in this direction. This is the direction of the flow based on the given direction here. For example, if we have a current source, and this current source is 2 ampere, this means this source is injecting 2 amperes in this direction. So it doesn't matter what is the circuit you are connecting this source to, this source is injecting 2 amperes, regardless on what you are connecting between these 2 points. Now, what will be the unknown in this situation? The unknown will be what is the voltage between these 2 points. What is the voltage difference between these 2 points? So the unknown will be the voltage as a magnitude and the voltage as a direction. Which terminal of these 2 terminals has a higher voltage? So we will assume the voltage here positive and the voltage here negative, and this voltage is unknown. Now we will come to a point which is the assumption of the direction. How to assume the direction for sources. And assuming the direction for sources means we are assuming the direction for the voltage, or we are assuming the direction for the current. So we will assume the direction for the voltage if we have a current source, or we will assume the direction for the current if we have a voltage source. So say we have a voltage source, and this voltage source has negative and positive, or we have a current source, and this current source has a current going in this direction. And this voltage source is 4 volt, and this current source is 2.5 ampere. So what will be the unknown for the voltage source? The unknown will be the current, and this current is unknown as a direction and as a value. So what someone can say, okay, I will assume that the current is going in this direction, and this current is unknown. Then he will go and solve the circuit, and after solving the circuit, he has 2 probabilities. One probability is that he will get a positive value, and if he get a positive value, this means that his assumption was correct. Or maybe after he solves the circuit, he will get a negative value, and the negative value just means that the assumption you assumed at the beginning is not correct, and actually the current is going in this direction. So the assumption of the direction is not a big deal. You can assume the current anywhere. If your assumption is correct, you will get a positive value. If your assumption is not correct, just you will get a negative value. So when you solve the circuit, you will know if your assumption is correct and not correct, which means you can assume the current going up or the current going down. Do any assumption. Any assumption is okay. Okay. For the current source, also we can do the same. So we can say, or we can assume, that the polarity of the voltage here is positive, here is negative. Again, this is assumption. And then you will solve the circuit and say you got the voltage as positive, which means your assumption was correct. If you get the voltage as negative, this means your assumption was not correct, and what you need to do, just you will reverse the two here if the assumption or the value you get was negative. But instead of having or allowing students just to assume the voltage or the current in any direction, then we will have multiple solutions and this will be a little bit confusing. Let's make an agreement on how the assumption will be done. So this is the agreement, or this is the way that we will do the assumptions. So the way that we will do the assumption for sources, the logic is to assume it is supplying power. So the logical assumption for sources, that we assume that a source is supplying power. And the source will be supplying power. The source is supplying power if the current I is leaving the positive terminal of the voltage. So say you have a battery. Here is the battery. And this battery has a positive and negative. If the current is leaving the positive, this means this battery is discharging. But if the current is entering the positive, the current is coming this way, this means this battery is charging. So the direction of the current with respect to the voltage will indicate if the battery is being charged or the battery is being discharged. So if the battery is being charging, this means it consumes power. If the battery is being discharging, this means it is supplying power. So the battery will be consuming power or supplying power based on what is the circuit it is connected to. So say here is your cell phone. Okay, and inside your cell phone here you have a battery. So if your cell phone is disconnected from the charger, this battery is the main supply of the cell phone, and this battery will be discharging. But if you connected the charger here and you plugged it in, now this battery now is connected to a circuit with higher voltage, and now the battery is being charged. So the same battery can be charging or discharging based on the circuit it is connected to. So it's a good assumption to assume the battery at the beginning is discharging or supplying energy. Then you solve the circuit and see if your assumption was correct or your assumption was not correct. So here we have a circuit and we have a source connected to this circuit. We don't know what will happen when this source is connected to the circuit. Will this source charge or this source will be discharging? Is there another source inside this circuit that is more powerful than this source, so this circuit will charge the source? Or the source you have here is more powerful than the circuit and it will give the circuit power? We don't know. We don't know what will happen. So what we will do, we will give it the benefit of doubt. So we will assume that the source is supplying energy. So we will assume the current is going in this direction. And we will solve the circuit. We will solve the circuit using circuit analysis, as we will learn. If we got I positive, so the assumption was correct. If we put I or we got I negative, so the assumption is not correct. So what you will do if the assumption is not correct, just you will do nothing. Don't change anything. Okay, so if you say that the current is going in this direction as 5 ampere, this is totally fine. Or you can say that the current is going in this direction as negative 5 ampere, totally fine. It's the same information. You are telling me the same information. You are telling me the current is going left to right as 5 ampere, or right to left as negative 5 ampere. So if you got a negative value in the exam, just leave it as it is. It's correct based on your direction. So to summarize, whenever we will have a source, say we have a voltage source like this, or we have a voltage source like this, we will assume that the current I is leaving the positive terminal. So we will always assume I is leaving positive terminal of the source. And we call this source notation. If it is a source, we will give it the benefit of doubt and we will assume it is supplying. So what if we have a current source? How we will deal with it? So if we have a current source, so you know where is the direction of the current. Say it is given that the current is going in this direction as 3 ampere. So what will be the unknown? What you need to determine by solving the circuit, we need to determine what is the voltage between these 2 points. And this voltage is a magnitude and direction. So where is the direction is, we have to assume it. How we will assume it? We will assume that the current is leaving the positive. So I will assume that there is a voltage V here and this voltage is unknown. So the assumption again for the source, that any source has a positive current leaving the positive terminal. And this is called source notation. So in summary, any source will represent one unknown for you. This unknown can be a voltage if you have a current source, and this unknown will be the current if it is a voltage source. So whenever you see an element and this element is a source, an independent source, this means you have an unknown here. The second type of sources are called dependent sources. And dependent sources has the symbol, this symbol. When you see this symbol, this means it is a dependent or controlled source. So this is a dependent, or sometimes we call it controlled sources. So when you see this symbol in the circuit, this means this element is controlled, or this element is a dependent. And dependent elements means it depends on something in the circuit. And again, the dependent element or the dependent source can be a voltage source and can be a current source. If it is a voltage source, you will see a positive and negative polarity for the voltage. If it is a current source, you will see an arrow indicating where the current is going. So the source here is a dependent voltage source, or we call it controlled voltage source. This symbol here indicates that we have a dependent current source, or we call it controlled current source, CCCS. Then if you have a voltage source, we said that the voltage source, you are given the value of the voltage. And if you have a current source, you will be given the value of the current in ampere. But for the dependent, instead of being given a direct value, you will be given a function. Here you will be given a function. For example, what if you are given a voltage source, and this voltage source has a value 3.4 I3, and this value is in volt. So the voltage difference between these 2 points is given to you, but it is given as a function. and this function is function of a current, and this current is I3, and I3 will be a variable in the circuit. Like I will give you a voltage source and say the value of this voltage is W or H. Now this source is a controlled source because its value is a function, not a given value, and this function is W or H. So what is the control variable here is your age. So we can call this an age controlled voltage source. So it's a voltage source controlled by your age. So you will take your age multiplied by 2, now you know the voltage. So still the value here is given, but instead of being given directly as a value, it is given as a function. So if the function or the voltage is function of the current, we call this current controlled. And because it's a voltage source here, so we name this as current controlled voltage source, or CCVS. Another example, if you are given say you are given voltage source as 2.85 V P, and this value again is in volt, and this is given to you. It is sketched in the circuit, and it is mentioned that this source has a value of 2.85 Vp. So what is the meaning of this? That the voltage difference between these 2 points is function of another variable called Vp. So once you know Vp, you know this value. And as this value is a voltage, so your control variable is voltage. So we name this as voltage controlled because it's controlled by voltage, and the element here is voltage source, or we give it the symbol VCVS. Similarly, we can have a dependent current sources. So for example, if you have dependent current sources, let's take an example. If it is given in the circuit that you have a dependent source, and this dependent source is current, and the function given as 2.43 IN. So the value of the current of this source is 2.43 IN, and the current coming from this current source is going in this direction. So the control variable here is current, so this source is current controlled, current source. So the element itself is a current source, and it is controlled by current, or we give it the symbol as CCCS. Or you can be given a current source again and say this value is 0.483, any number, Vx, any voltage, and Vx will be given or defined in your circuit. So what we have here, we have a current source, and this current source is dependent, and it depends on a voltage. So the control variable here is voltage. So this is a voltage controlled current source, or VCCS. So these are the types of dependent sources that we can see in any DC circuit. So let's add another page. So to summarize, the independent sources, the dependent sources, we have 4 types. So we can have voltage controlled voltage source, or or current controlled voltage source, voltage controlled current source, or current controlled current source, and this value here, the value here will be given as function of Fn is means function of voltage, and this value here will be given as function of current. This value here will be given as function of voltage. This value here will be given as function of current. So for example, the value here is given as 3 Vx. The value here is given as 2.5 In. The value here is given as 3.8 Vn. The value here is given as function of current, say it's 4.8 Ix. So these are the types of dependent or controlled sources that you can see in any circuit. So this is what you will be given for you, function, okay? And this function, just if you know the variable in this function, you know the value. So what will be the unknown if you see this dependent element in your circuit? So if the element is a voltage source, we said that the unknown will be the current. If the element is a current source, the unknown will be voltage. So here the current is unknown, here the voltage is unknown. So how we will assume it? The rule is we will assume that the current is leaving the positive terminal. This is the rule. So we will assume the voltage here, so the current again is leaving the positive terminal. We will assume the voltage here, so the current is leaving the positive terminal. So whenever we have a dependent source or independent source, we will assume the value of the voltage or the value of the current, so the current is leaving the positive terminal. If the source is a voltage source, we need to calculate its current. This is the unknown we are looking for. If the source is a current source, we need to calculate its voltage. This is the value of the unknown. So any dependent or independent source is equivalent to one unknown in your circuit. We will see how we can deal with these unknowns later on. Now, the second type of elements is loads. Okay, so we finished the sources. Now we will start the second type of elements, which are loads. So the second type of elements is loads, and under this category we have R resistance, or we have L inductance, or we have C capacitor. So let's start by resistance. So we use this symbol to represent a resistance. This is the symbol we use for a resistance. And you will be given a value for this resistance, and the unit for this value is in ohm. Okay, so you will be given an X value, a value for the value of the resistance in ohm. So this is the resistance R. Now, if you have a resistance, it has two terminals. So between these two terminals, there is a voltage difference that we don't know what is the voltage difference here. And also there is a current going. This current can be going down or up, so there is a direction also. So if we have a resistance, we don't know where is the current is going, what is the value of this current, where is the voltage polarity, and what is the value of this voltage. Which means we have almost four unknowns: direction of voltage, direction of current, value of voltage, value of current. But actually, the voltage and current are related together. How the voltage and current are related? They are related using Ohm's law. So Ohm's law is V equals Ri. And students forget that this equation is a directional equation. So actually this equation is directional equation. So what is the meaning of directional equation? That Ohm's law is assuming that we have a load. So this is for loads. And for loads means that the current I enters the positive terminal of V. So you cannot write down Ohm's law V equals IR without making sure that the current in the equation and the voltage in the equation, they have the directions, so the current is entering the positive terminal of R. Let's take an example. So if you have a resistance and this resistance is 3 ohm. Now you see this resistance as an element in your circuit. So what is given? You are given a resistance as 3 ohm. What you need to calculate to solve the circuit, you need to calculate the current and the voltage. So let's assume the current. So we need to calculate the current, so we have to assume a direction for the current. So say, and this is up to you, it's totally your choice, you can assume the current going up or down. Say you assume that the current is going up. So this is an assumption. Now, where you should assume the voltage? Once you choose the direction for the current, the direction of the voltage is not optional. So you have to follow the Ohm's law rule if you are going to apply V equals IR. So in this case, we have to assume the voltage as positive here and negative here. So the current I is entering the positive. Now you can write down that this V equals 3I, and this 3 is the value of R. And you can apply Ohm's law. So you cannot apply Ohm's law without having this condition satisfied, that the direction of the current I is entering the positive terminal of the voltage. You have to make sure that you are satisfying this condition before writing this equation. So when we have a resistance in the circuit, actually it represents one unknown. This unknown can be the current or the voltage. Why it is one unknown? Because if you know the current, you can use V equals IR to get the voltage. Or if you know the voltage, you can use I equal V over R to get the current. So actually a resistance is just one single unknown. It is not two unknowns. So if we have a resistance in the circuit, so a resistance is equivalent to one unknown. And this unknown can be I or V. Can be I or V. But once you assumed one of them, the other one is not unknown. Now the other one is already related to the first one. So if you assumed the current, the voltage is related to it. If you assume the voltage, the current is related to it. So to summarize, whenever you are seeing an element called a resistance, and this is how the resistance is shown in the circuit, when you see this element, you know that there is an unknown here. I need to find this unknown. What is this unknown is? The current or the voltage. How you will assume it is totally free choice. Choose the current going up or down, the voltage positive or negative, anywhere. But once you assume the current or the voltage, you don't have the option to assume the other variable. So if you assumed the current, you don't have the option to assume the voltage. And if you assumed the voltage, you don't have the option to assume the current. The rule is that the current has to be entering the positive terminal of the voltage, which is called load notation. And this is the opposite of source notation. So let's add a page here, and let's see this example here. So I will take a copy of this. Now, if you have the circuit, so if you have the circuit, okay, so this circuit is given to you. So how many elements we have in the circuit? So we have in the circuit, we have an element here, and this element is independent. You can see here from the symbol that it is independent. We have an element here, and this element is independent, and we have an element here, this element is independent. So we have three independent sources. The source here is a voltage source. The source here is a current source. The source here is a voltage source. So we have two voltage source and we have one current source. So we have two voltage sources and we have one current source. Now what is given? So for this voltage source here, you are given the value of V1 and you are given the direction of V1. For this voltage source here, you are given the direction of V2 and you are given the value of V2. So in the exam, these will be numbers. Just here we use symbols as an example. And for this current source, it is given that the current is going in this direction and it is given the value of this current as I1. We said any source in the circuit means you have one unknown. So for this voltage source here, there is one unknown. What is the unknown is what is the current supplied from this source. So how we will assume the current, we will assume it leaving the positive terminal, and this current is unknown. Here we have a voltage source. So what is unknown for the voltage source is the current. How we will assume the current, we will assume the current is leaving the positive terminal, and this current is unknown. Here we have a current source. What is given? You are given the current as value and direction. So what is unknown is the voltage. How we will assume the voltage? We will assume the current is leaving the positive of the voltage, and this voltage again is unknown. So now we have three unknowns for these elements. Now let's continue. What we have else in the circuit? So we have in the circuit, we have a resistance R1. What is given for the resistance R1? You will be given this value in ohm. It will be given. So what is unknown for this resistance is the voltage across it or the current going into it. How we will get the current or the voltage? So let's say that we will assume the current here, it's totally a free choice. You can assume the current going this direction or this direction. It's totally up to you. It will not affect the solution. It will not affect the numbers you are getting. So say I will assume that the current is going in this direction and this current is unknown. And once I know this unknown current, I can get the voltage across the resistance, and here will be the voltage. Why I assume the voltage as positive and negative here? Because I has to be entering the positive of a resistance, because a resistance is a load. So it's opposite to source notation. So for sources, I is leaving positive terminal. For loads, I is entering the positive terminal. And this voltage is not now an unknown or independent unknown. Because if you know the current I, just multiplied by the value of R, you have the voltage. So we have three resistances. So for the second resistance here, I can assume the current going up or down. Say I will assume the current going down, and this current is unknown. And I will assume here is positive and negative, so the current is entering the positive. We have four resistances, not three. And here we have another resistance here. So say I will assume that the current is going, it's totally my choice, going this direction. And the voltage will be positive, negative. For this resistance here, I will assume that the current is going in this direction. And this current is unknown, this current is unknown. And if the current is going this direction, so the voltage will be positive and negative here, so the current is entering the positive. So how many unknowns we have now? We have four unknowns. So in total, to solve the circuit, we need to calculate 7 unknowns. And to solve the 7 unknowns, we need 7 equations. So we need to be able to write 7 equations so we can solve the circuit. So what are the seven unknowns? The current of voltage 1 and the current of voltage 2. This is 2 unknowns. And we have the voltage of I1. So the voltage of this I1. And we need the current in resistance R1. And we need the current in resistance R2. And we need the current in resistance R3. And we need the current in resistance R4. So these are the 7 unknowns we have. The current, say this is the current of V1. This is the current of V2. Here is the voltage of I1. Here is the current of R1. Here is the current of R2. Here is the current of R3. Here is the current of R4. If we solve for these 7 unknowns, we solve the circuit. The question is how you will write down the 7 equations, how we will get the 7 equations. This will be the topic for our next lecture, is how we can write down equations. And to write down equations, we will learn about KCL and KVL, or Kirchhoff's law. So we will learn Kirchhoff current law, and we will learn Kirchhoff voltage law, or we will learn KCL and KVL. So next lecture, we will learn KCL and KVL to get the equations. So I will stop this lecture here, and we will continue during our next lecture. And thank you.